Now, creating the mass hole diagram. From Analyze, choose Mass Hole, create Mass Hole diagram, General page, select Alignment Road A and Sample Line, Mass Hole View Style, Basic, then Mass Hole Display option. Here you define Material List, Material 8, Cut and Fill, and choose Total Volume, representing the full earthwork behavior, and Mass Hole Line name, then Balancing options. How will Civil 3D interpret hole? This is where engineering meets economics. First, free hole options. Choose free hole distance and enter 300 for this example. Material move up to 300 meter considered standard rate hole, no cost penalty. Beyond this, Civil 3D calculates overall. And here in add or remove borrow pits and dump sites, you can input type, borrow or dump, or here station and capacity. Civil 3D will utilize these automatically during balancing, giving you elastic earthwork flows. Now create diagram and put it here above the profile view. Thus, the mass hole diagram has been created as shown on the screen, but we observe that the excavation quantities are much greater than the fill quantities as shown here. Therefore, the balance line is not visible. We must refer back to the profile and redesign the vertical alignment here so that excavation quantities equal the fill quantities as shown. For example, this point, move it to here, move it to here, also here, and here, also here, and here. Then rebuild the corridor. And this is the result. To increase vertical exaggeration, select the mass hole diagram, then edit mass hole view style. From graph, increase vertical exaggeration to 5, then apply, then OK. Don't forget to like, subscribe, and comment your question below. This graphic illustrates a mass hole diagram for Road A. The grid behind the curve is the mass hole view, and the curved line you see represents the mass hole line, a continuous plot showing the cumulative earthwork volume as we move along the stationing of the project. As shown here, two shaded regions appear along the diagram. Some areas lie above the balance line here. This is balance line, indicating net cut accumulation. Other lies below it, indicating net fill accumulation, as shown here. The color patterns shown here as blue and red represent the diagram's interpretation of a free hole versus overall, depending on Civil 3D style being used, axis and balance line. The horizontal axis represents the stationing along the road A, and the vertical axis is the balance line which marks where cut equal fill. Wherever the mass hole line crosses this axis, we have balance points. Now, understanding line behavior. The slope of the curve indicates the type of earthwork. As shown here, raising curve cut region, the higher its clamps, the more cumulative cut is being generated. And descending curve here, fill region, the sharper drop, the more fill the project is consuming. And here, peaks represent transitions from cut to fill. And here, in valleys, represent transitions from fill to cut. These are known as grade points, crucial for identifying hauling strategies. Now, freehaul versus overhaul shaded areas. The shaded regions are the core economic component of the diagram. Freehaul, movement of material within the allowable hauling distance at the standard rate. Overhaul, any haul distance beyond freehaul limit, which incurs additional cost. Depending on your official standards and diagram style, blue may represent freehaul, and red may represent overhaul. Civil 3D allows full customization, so verify this in the mass hole line and view style. Reading the diagram through the project. The mass hole line begins by raising sharply above the balance line. This tells us the project starts with the cut-dominated sections. The shaded patches illustrate that. A portion of the cut is economically moved within the freehaul zone. The remaining cut, which must travel further, is counted as overall, but in mid-project transition, later curves downward and crosses the balance line. This marks the beginning of the fill region. If the previously generated cut is insufficient to fill this zone within the freehaul limit, we begin to see overhaul or the need for borrow sites. Final segment in right side here, the curve dips well below the balance line, representing sustained fill demand. Toward the end, a small upward turn may appear, either signifying a minor cut region or indicating imported fill arriving from a borrow area, or giving a sign that surplus material must be wasted in dumping site. The final elevation of the curve relative to the zero line tells us whether the project is globally balanced or whether import or export is required. Watch the next lesson here to continue the workflow. Don't forget to like, subscribe, and comment your question below.